Hey, look which one I got. Look what I got. Here, Elizabeth, go choose a pretty color that you like.
As you know, small science is something that started almost a quarter of a century ago, and for all these years, it has not left me. It's not something which I've been able to leave behind and go on. Um, and it's a real privilege for me to be here and to kind of share with you where it has come from and where I find myself now in this whole journey. It started with, in fact, our director at that time, Arvind Kumar, said, why don't we design a science curriculum? It should be the Homi Bhava science curriculum. And so he said, let's start at the primary level, and he asked me to do it. So this, I had never thought that of actually writing a curriculum, although I had, worked in studying children's conceptions and looking at teacher-student interactions in the classroom. So it was really a kind of natural way to go. But it was the first time I gave some thought to it, and I found that there is an inherent contradiction in writing a textbook which is connected with your everyday experiences. There is a contradiction in trying to write a textbook which you expect to be used pan-India and therefore to be locally relevant. But what is local? It is so varied. I mean, we have such wonderful diversity in the country. And the textbook itself, how do you get a textbook to connect you to the everyday work? A textbook, just makes, you read the textbook, right? How can you go outside the textbook? And at the primary level, we were convinced that there are not too many facts that you need to learn. Sorry, I hope you can. Yeah.
Go ahead, Jayashree.
Yeah. So it's not, the facts are not that important, particularly at the primary school level, but there are some facts which are important. So the challenge is to see which are these important facts, which are the facts which one needs to teach, what is the information, what is the minimum information that one needs to give. And if one is not going to give facts and information, then what is one going to give in a textbook? So this was a question that we grappled with in designing small science. And I think the answer came in questions. So finally, the way the small science books came about, there are a lot of questions. I mean, the textbook only has a lot of questions and it has activities. And we found that questions had a power to focus learning, which to focus learning, to get the children out from the textbook to observe the environment. So this was, I think, a key insight that came through small science, and it kind of took us out of this conundrum of making a textbook relevant to everyday life. So what is this new role of the textbook? And I hope you can read this document. It's is the font okay?
Yeah, it's
Yes,
fine.
yes,
Absolutely
Jayashree.
fine.
Yes.
Absolutely fine.
So how do we redefine the role of the textbook? And here, let's put it this way: to equip students to observe their everyday world, to analyze and seek patterns in these observations, and to express their own learning. So the textbook should enable the child to observe, should enable the child not just to observe, but go beyond that to analyze the observations, to seek patterns in them, and then to express themselves orally and in writing. So this is what we wanted the textbook to do. And, over the years, it resulted in these textbooks, workbooks, and teachers' books for classes 1 to 5 that were published by the Homi Bhabha Center for Science Education. The originals, originally they were written in English, and then they were translated by various people into Hindi, Marathi, Urdu, Odia. Most recently, they got translated. And there are also kind of so far informal translations in Tamil, Kannada, Bangla, which have not been published. Okay, so now let me show you a few slides from, so what is small science about? And so this is this older presentation. Can you see it?
Yes, Jayashree. Yes.
Yeah. So I'll go through what the small science approach is about. And see, the key to it and the problem which it addresses in students' learning, it begins with a contrast that we saw in our previous research between rural students and urban students. And we found that rural students have a lot of rich experiences of the environment, but often they lack the language to express them, the means to systematize them, and ways of expressing that would make that informal knowledge, move it towards formal learning. On the other hand, urban, city students often focus on just bookish learning, and at the expense of ignoring their natural surroundings. So the approach that we took with small science is, like I said, asking questions, making sense of the natural world. The experiences of the natural world need to be organized in certain ways so that they make sense. And these are just everyday experiences. They are not exotic experiences. They are not sanitized, just experiences in the raw. And, recording them, analyzing them, making sense of them. So an example is a decaying banana peel. So you eat a banana, and if you just drop the peel, what happens to the peel? And these drawings that you see are from the class 4 book drawn by Karen Haydock. And she actually, did this, just kept a banana. She lived in a place where there was a tree outside and some dry leaves. And she watched the banana decaying over maybe 2 or 3 months, it might have been. And she just drew what it looked like. And then we had an activity in the textbook, which was based on just watching a banana peel decay. And now the observations you need. So, we started with saying that we are not going to teach facts. Then what are you going to teach? So what we wanted to teach was the tools for learning and the tools of thinking. And we, the tasks that are needed to, engage with the world is observing, drawing, recording, analyzing, expressing, discussing, arguing. These the later parts are very important, and writing down, communicating your findings with peers, all of these are very critical for the learning to happen from the informal observations. So systematizing these observations and introducing skills of quantitative thinking, language skills, design and engineering, and I'll just give a few examples of these. So this is an example, and actually you'll find many of these examples since then have found their way into many textbooks. They're not really that new anymore. So here are some examples. Try planting not just seeds, but dals, grains of rice, or sago, sabudana, and check what sprouts and what doesn't sprout. And then guess if things that did not sprout, why they didn't sprout. And then observe, the sprouting and the growing of the seedling. In these observations, something that we had to take care of was that students have their own spontaneous ways of thinking, which we need to address in the classroom. And to address these, first of all, we should know what are these spontaneous conceptions. So this is an example from the teacher's book. Okay, so I think, let me just backtrack a little. The small science series consists of a textbook, a workbook, and a teacher's book. Textbook has the questions and the exercises and activities and exercises. And the workbook has a format for recording these. Now, all of these, this material, this content, we tested in the classrooms before actually putting it down in this form. And the results of this testing you find in the teacher's book. And this is an extract from the teacher's book. It actually, it's recounting something which happened during the testing. So this was, noticing that water condenses on cold surfaces. So you put a bottle of cold drink in the refrigerator, take it out, and find that it gets wet. Then you wipe it, and it gets wet again. Now, how do children interpret this? The idea of water vapor condensing on a surface is a very, very abstract one. First of all, the idea of water vapor existing in the air is abstract. In fact, the idea of air itself is abstract. So there is a whole lot of steps that the kids have to go through to understand what is this happening, which we call condensation. And, you see what kids are saying, that maybe it comes from inside. Maybe it's a cold drink that's come from inside the bottle. Other kids didn't think it was likely. Now, here, what is important is the argument which happens in the classroom. So the kids on one side say that it can't have come from outside because it's not sticky like the cold drink. Or there are no holes in it, it doesn't leak, how can it come out? Or if there is warm water, it doesn't come out, why should cold water come out? All these arguments came from the kids. And so actually, we were really thrown when these arguments came from the kids. But later I have found many teachers have recounted to me exactly the same, very similar arguments that come from their kids in their classrooms, very different classrooms. So it's very striking how children come to these conclusions on their own. And we have to be sensitive to this, and we have to take care of it in our teaching. So still on observations, recording observations in drawing is a very important part of the small science approach. And it begins with giving a value to children's drawings, not just seeing them as something that is done on the side, but a tool for learning and thinking, for self-expression, for creativity. And using these drawings to notice similarities and differences. Notice, draw, observe drawings, observe reality, compare. All of these things come into it. This is an example of analysis following from observations. So the children had to observe musical instruments, and here we'd given the pictures of the musical instruments, knowing that kids would not have seen a lot of musical instruments. Maybe they knew a few, but we drew a whole variety of musical instruments. This was again Karen's drawings. And then they had to make this Venn diagram and see how these instruments make a sound. Do you blow air through them? And there are basically only three ways in which musical instruments make a sound: through blowing or beating or vibrating strings. And classifying these instruments using a Venn diagram, seeing that in fact some instruments there is an overlap. You use 2 or 3 different kinds of ways to create, for example, a harmonium. You use more than one of these methods. So the kids kind of hone their analytical skills at the same time that they are classifying their observations. There's a lot of tabulation in the workbook. And many of the exercises involve either tabulation or graphing. Then many exercises based on quantitative thinking. There's some examples here. So we started with teaching graphs in grade 3, and you introduce graphs through pictures. In fact, not in grade 3, even in grade 2, there is an example of a picture graph. So you begin early, but begin in the entry point should be accessible to kids at that age. That's the idea. So then developing language skills. Like I said, instead of teaching facts, we wanted to develop tools for learning and thinking, and language skills are most important here. And there are exercises which get the kids. First of all, the book has stories and poems, and then there's opportunities for the children to use sound in a fun way, use words in a fun way. Orally expressing their observations, writing them down, asking questions, etc. And design and engineering. So there are several activities in which the kids have to construct. So they make a house, they make bricks, dry them, and build a house using these bricks, or making a water wheel. This was one really favorite activity of children, because they got to play in water. And all through this, there are certain values which we tried to ingrain in the way that the activities and the exercises were framed and conveyed. So being sensitive to social issues like inequality or differences in the opportunity, even within the classroom, the way you share food, the way you talk about dress and various things. So all of these values we tried to build into the curriculum. That all living things have value, conserving resources, working with the hands. feelings and emotions, that they are not separate from science, that they come into our everyday life and our learning also. These are the textbooks which are there. So there are totally 10 books. There is the textbook I already mentioned. It interweaves a story about two children, Minnie and Appu, who learn by doing and asking questions. The workbook gives a format for recording. It's also used for continuous evaluation. It provides feedback. The teacher's books have first-person accounts. So I mentioned that we trialed all the activities in the classroom, and the teacher's book are an account of these as told by the teacher who did these activities in the classroom. But it summarizes, we tried it in maybe 2-3 classrooms, and then it summarizes the collective teaching experiences of these field trials. It also gives examples of students' responses and how to keep students engaged, various suggestions for that, how to handle classroom discussions. This is just a list of the books in English, Hindi, Marathi, Urdu, and the Odia books are not listed here. We have been getting wonderful feedback from teachers, which continues to come even till today. These are some comments from a teacher who used these books. He was a Teach for India fellow and taught in a municipal school in Pune. Since the books have been in use for so many years, even in 2012, we found one of the students who had used them in the very early years. She was in college, and she came to the Homi Bhabha Center, just to see where these books came from. And so she says, Small Science was the first book that was compelling to me. After all these years, and then I spoke with her mother, and she said that, we've moved from place to place, and she just will not let me throw away those books. She still has kept them. So, of course, all this is nice, but bringing a curriculum into practice in classrooms is not straightforward, as I'm sure that all of you know. And we had a couple of evaluation studies. After a few years, there was a couple of evaluation studies, and basically they pointed to more teacher support that we need. I recently checked with Homi Bhabha Center how many book copies have been sold. So about 2.7 lakh print copies have been sold over 24 years. Mostly they have been in English, although some Marathi ones have also been sold in Hindi. Over the past few years, if you check, about 5,000 copies per year are still being sold. And the latest estimate from Homi Bhabha Center is there are about 30 schools that are using it directly. And of course, many more use it as a resource. Here's some more comments from teachers. And some of these, so recently there was a survey which we sent out with Roshni and Veena help and Radha, we designed this survey. And so some of these comments come from the survey, and some of these comments are from earlier. I don't think I need to read them out, but this one I was really struck by. I mean, I found it really gratifying because it is the one in green. Children who learn small science are stronger in basics when they come to middle school. And I was so pleased to see this. I mean, this is something which we wanted to happen, but one can't know how it will go. But this is a comment from recently in the survey. Okay, so there are all this high praise, lot of appreciation for the books. It's been wonderful to see how many teachers have appreciated these books. Of course, the ones who appreciate are always forthcoming in conveying their appreciation, and perhaps there are many more who have not appreciated. And some of these expressions are here. So, teachers often, in fact, they ask me that what do you do? This doesn't, what kind of assignment do you give to children? Or there are no definitions. What do they have to learn? Why doesn't it have color photographs? I mean, this is a very common, reaction from people that and this teacher says it. My first impression was like, this book doesn't have text to read. It's full of black and white images. And here's one more. Kindly add content in the workbook as it is full of activities. So clearly, teachers find these books very different. There are these teachers who have been looking for such books, so there is also this, and when they find small science, they've said that, we have been searching for books like these in science. Fortunately, we got the small science book. So there are teachers who are already prepared and, are ready to get into it. And then there are teachers and parents and others, who still find it strange. The kind of difficulties that teachers have faced, a couple of these, which I found in the teachers' responses. So this teacher says, earlier it was very difficult to tell them that you have to write. So writing on your own, writing your own observations is not something, even after all these years, it's not something that's common. So children are a bit bewildered. How do you write? They're used to copying from the board, and how do you write your own observations? So this teacher says once they were into the system, they knew that and were more than excited to write. They would say which page and start writing in the workbook and so on. They were really excited. And this helps to get the excitement into the teacher also. But of course, this is one teacher's experience, but especially where English is not very well spoken, or it is this writing is a difficulty, or even with the Hindi books, we found that kids may speak Hindi, but they are not used to writing in Hindi. And that is one of the reasons which we found that, for example, Delhi SCRT considered adopting the books at one point, but they said that, our children will not be able to write, the Delhi Municipal School school kids. So writing, unless the kids have developed a good language competence, orally describing and writing is, the language classes also have to be in pace with the science classes for this to happen. Then a very common problem is time. And this teacher says if a teacher is teaching multiple subjects and is expected to complete certain topics within the school timetable, the books can seem overwhelming in their scope and their breadth. And I've heard similar comments from other teachers, she says. But also, there is a teacher who says that initially, in fact, there's a principal's comment. Initially, it was difficult completing all the activities. Later, we started the vertical approach for water and air for classes 3 to 5. We found that we had ample time for everything. So I guess schools which have more flexibility in structuring their classes were able to do it better. And overall, the need to have some kind of teacher support. So here again, it is a teacher, perhaps some of you are in the audience, so I'm sorry, I don't know the names of people who have said these things. But this is from the survey, that teachers require a lot of training and preparation of the process and the ways of thinking. And they rarely engage with the details unless handheld through it. And yes, we did find that schools which used the book successfully had a mentor, perhaps a head teacher or a supervisor who had got the idea and then were able to guide the teachers in this. One thing that we were able to do, however, only for I wish we could have done more of this. Teachers would document their experiences. This is where teachers have documented their experiences. And this actually, there is a kind of positive feedback that comes about when teachers document their experiences and then they see them on the website and they're able to share them. Sometimes the students also see them. It provides a positive feedback for them to continue with doing. So there are some suggestions which have come from this survey, but perhaps some of you could pitch in at this point. These are a couple of suggestions that came from this survey that we conducted.
So I'm Anisa, and I was running a school in Chennai, and we were using the small science books for almost 10 years across grade 3, grade 4, and grade 5. And we were really privileged to have Jayashree come and spend about a year with us, kind of mentoring me in how to work with these books. I mean, I don't want to say teach these books because this book is actually about doing the books, right? So, and that really completely changed my view about science learning and how to work with children. For me, these books were a godsend, really, because they really worked with, it was not about knowledge, but it was about thinking. So children really had to think, they had to express their thinking. And as I said, it's not only about knowing to write and therefore writing, but they learned to read, they learned to write using these books, they learned to observe, they learned debate and argument. This is the favorite class in school, and we did have the flexibility, so we would pretty much devote a whole morning to small science whenever we did it. And then I would also use the workbooks to have a back and forth with the children, like they would share their thinking and then I could, write stuff in it and give it back to them. And then we were able to actually do some of this in the lockdown also, which was very odd because small science is really about sitting in with the children, usually, outside under a tree and being outside, being with nature. But we did manage to do it in under those conditions too. So that really is a testimony to the books. That's Anything else you'd like me to?
Yeah, so I just wanted to add, Anisa, that the small science, the session that, at least one of the sessions that you did during the lockdown is documented.
Yes.
In the small science site, and I think another couple are documented in the Savaliram site.
Yeah.
Also. Yeah, so
Jayashree, can I request you to quickly tell me?
Anisa, perhaps Anisa, you could tell people about what your kids went on to do after small science.
Okay, well, depends. We were a small school, so and that just adds to the personalization we could use for small science. But I think definitely what small science did was it gave children a notion of science as a practitioner, not as something to be learned, not something cast in stone. So the first thing I could say is the children definitely had a questioning mindset. They had a very keen sense of observation. I mean, even today, my daughter, today she was saying we have this thing called tempeh. Let's keep it in a jar and watch it for 7 days and see what happens to it. I mean, now she's in third year college, but that sense of wanting to test things out and poke and prod, which is the essence of scientific thinking, stayed with all the children. I think that was the main thing. It was not about what they remembered, but what skills they picked up in observation and things. A lot of these kids actually took part in the what are they called, science fair things, science fair competitions that would happen. And what was nice was that the children could come up with their own questions that they want answered through the small science fair process, right? It was not about canned stuff taken off the web. That I think to me, Jayashree, that was the biggest impact, that mindset. Then of course they went on to do engineering or medicine or whatever, and so went on to psychology. That's so many other factors that play into it. So I think what's most important is who they became and how they thought, more than the degrees or things attached to the names.
So Anisa, also they had this first round of writing books, and then your second round, the Earth Authors.
I'm sorry, I forgot that. So the children wrote books, and these storybooks on nature, and the latest round is actually listed up on Amazon and stuff. But essentially what my feeling very strongly all the time had been the empathy and the observation that they learned, the love for nature, love for environment. It was rooted in their early experiences with small science, because it's a very living curriculum. It's something that that the teacher and the children evolve in the classroom. I mean, the contradiction that Jayashree talked about, the textbooks being fixed, and then what do? How do you localize a textbook? I mean, that's a very big challenge. But because the nature, the way the textbooks are, it was living. It was not just me working with them, but the children actually evolving the curriculum. So.
Thank you so much, Anisa. That was really nice. And yeah, it was wonderful, I think, a few years back also, to read some of your blog posts and how you used the small science textbooks and the observations by the children. I remember Jayashree sharing that with me, and it was so wonderful to read that. And a lot of the inspiration of the work, from the work that we do right now, also comes from, experiences such as yours, Anisa, from your own kind of recording of a lot of these observations, and from the small science textbooks. So thank you for whatever you're doing.
Thank you, Anisa.
So basically, wonderful. It was really nice listening to you, Professor Jayashree. And I've been working with environment education. I know it is science, and it may not be science to the extent to which you have been able to introduce concepts. But my question is very simple. We understand this methodology, this way of working is extremely important. The fact that we are able to reach out to children with much more meaningful learning. Why are we not able to mainstream this? I mean, considering that you have textbooks and you have been able to sell textbooks over so many years to different schools, but why is it that the NCRT or others in the state education textbook boards do not understand the value of this format of learning, and what is it that can be done still for us to kind of push them into understanding that this hands-on experiential learning is just an amazing way of learning for children? So that is basically what I have to ask.
Thank you, Ganvi, for the question. And do you actually work in a school, or are you outside of the?
I'm sorry, my name is. I'm not able to change my name. I am Sukhpreet.
Sukhpreet, sorry.
Yes. Just to very briefly introduce myself, I've worked with the Center for Environment Education for almost 17 years, and now I've been working. I work as a freelance consultant. So basically, my work has been to do with environment education. I have developed activities so that children learn about environment in a hands-on, engaging way. And the kind of examples that you were giving, like when you compared rural children to urban children, and the kind of contextualization that they do. So I will just give one example wherein when we ask children to study about, when we ask the schools to study about their immediate nature, and we say that you come back to us with your learnings, they still tend to do things like a secondary research. They don't necessarily do a primary research. So a secondary research doesn't give you the experience of a primary research. So in spite of having in place things like, okay, it has to be done in a primary research way, and this is what your learning is, it's difficult for even teachers to grasp that, primary research means this. I mean, just a simple thing like the pupa which the children brought, and they observed it and observed that it observe the entire metamorphosis into a butterfly, and then let the butterfly go. It's an amazing experience. Nobody ever has to teach you how metamorphosis happens or the changes, or even the example of the water bottle and the condensation on it. So these are things which I also have tried to build into my work, but the point is teachers are not, it's very difficult for them to, especially when it comes to some of the environmental sciences concepts, because environmental education is still an outside subject. It's not something which fits directly into your mainframe subjects like science or math or other subjects too. So getting schools to understand, it's very, very valuable. When someone does it, they understand the value of it, they really want to implement it, they don't want to give up on it. But it's such a task getting people to understand that this is such a valuable way of learning. It's such a beautiful format which can never be forgotten. You don't have to make the effort to teach, because the children start learning by themselves. So this whole aspect itself, it's an amazing journey. I mean, I love this way of working, and this is because this is also something I have been doing. But then I don't understand how to convince, why people are not convinced that this is the way it should actually be done, and not the way the textbook approach that we actually have to teaching and learning.
And so you said, how do you make them understand, the people in NCRT or state governments? That was your question, basically.
Yeah, they're the decision makers. So how do they understand?
So, the point is, there are actually enough people who do understand. And yet, why does it not happen? I mean, this has been my experience interacting with people at NCRT, with state governments. Many state governments, you find that NCRT books that were written post NCF, they drew a lot from small science. And various state governments also, you find a lot of activities from small science are there in state government books, and people, I've spoken with people. Several state governments have even considered adopting them, but it has not happened. So has NCRT. In fact, NCRT at one point, when Krishna Kumar was the director of NCRT, had proposed that NCRT could print and publish and distribute the books. along with the NCERT books and keep it as an option for schools. So all this has happened. The people do exist. It is the structure, the system, and the system has kind of various givens which this will need much more time to explain. But I think it is not conviction which is lacking at personal levels. And often even the decision makers are convinced, but they're not able to push it through, or there are blockages which come because of the system being rigid. Sorry, that's a very short answer to your question, which does need a longer answer.
That's okay. See, ma'am.
Our next, the next part of this session is going to be people's ideas about how we could go further, and I think I'd like to make some more points at that time. But I think your question is very, 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 very important. Thank you.
Thank you. Thank you.
I've been really excited by the small science books. We've never used them as a textbook or a workbook because of language problems, but they've been a very rich resource for us. But one of the things I've been thinking about, maybe this is jumping ahead about ways of looking forward, is how language is used in the small science books. And one of the surprising things is how much attention has been given to language in the small science books. The usual science textbook, the language of the science classroom, means that you have to be objective, impersonal, rational, narrative you avoid if possible, figurative language you avoid if possible. So I was looking quite closely at these small science books. And for example, there are stories, there is poetry, there are opportunities for children to express themselves. All that is there, and richly so. But I was just wondering how we might extend that, particularly in relation to stories. Most of the stories in the small science books might be described as everyday, descriptive accounts of investigations, which is a very valid way of using the language in the textbook. But I'm wondering what other ways we might have used stories particularly, and maybe to use poetry more than is there. So I came up with just a few very broad questions. What kind of stories are appropriate and why? Sometimes we think any story children will be interested. We have to be much more discerning about the kind of questions. What kind of stories are inappropriate and why? What makes a story memorable? I think this is the energy of a story is a rich resource. So what is it in a story that makes it memorable? When is a story not a story? And what are the elements of story? I think what are the problems and advantages of using anthropomorphism in a science textbook? So taking animals or birds and giving them voices, what are the problems there? in using fictional language, is it confusing for children? And at what age is it helpful, not helpful? It's another question. How can we use the language in a more literary way so it's engaging? So some of the poems, or for example, the water cycle in Kannada, there's a song about the water cycle. Can we use actually more engaging forms of language to convey life cycles in a different way? Can we use different kinds of language in a single textbook? So those were just beginnings of thinking about how we could go further, not just thinking of stories in general. What do we actually mean? Where could it lead? What are the dangers of not thinking through things carefully? So those were some of the things I was thinking about.
Thanks so much, Jane. Lots to think about and reflect.
Yeah, hi. My name is Vikram and I'm the founder and director of a school called the RM School in Raipur, Chhattisgarh. When we started the school, we did have, these books, some of the people from Krishnamurti Foundation, you suggested us to use this book. We did try, but, as some of the points which different people were sharing, that, it becomes very difficult to kind of, look at it in a kind of a mainstream thing where syllabus completion is more important than scientific mindset. So that is why I also mentioned in the chat box also that when you really want to use small science, what kind of support a school can expect from the organization, because only the creator knows the process. We can have our own way of interpreting the content. But when we do get some support from the organization and people involved, it certainly develops a perspective which can support children to learn in more efficient way. So if you can please guide us there.
Yeah, thank you, Vikram. I did see your question in the chat box, and yes, it is true that teachers need support, and we have done this from time to time. We have sometimes even had workshops held at the Homi Bhabha Center. Now I have been away from the Homi Bhabha Center for many years, but what I would suggest is that you write to Homi Bhabha Center and maybe even write to the director and ask if this kind of anyone could help. Yeah, it's quite possible that you might get some help from Homi Bhabha Center. And, I'm always there. I'm based in Pune right now. But, okay, so one thing I'd suggest to you is to join we have a WhatsApp group of small science users. And, you could be part of that. So what... at present, the situation is that after COVID, it's kind of quietened down. Otherwise, there was a lot of sharing of experiences that teachers used to do. But we could start it again. I mean, if you want to start using and, share your experiences, share your difficulties, there are people there who have used and many who are still using small science. So that's something that's possible. So do get in touch, and we can facilitate all these things.
I want to say, also responding to what Mr. Vikram had to say now, I feel very strongly that if we have to make an approach like this successful, then we have to believe, and we have to make our faculty, in this case maybe teachers and others, believe that making children understand the concept is much more important than the marks-driven approach our education system has arrived at today. So that is one thing I feel very strongly about. I really feel that today everybody, even parents, teachers, if you go to the school to ask them how my child has done, they'll only talk about marks. They'll only say, okay, if the child would have, the child is certainly capable of performing more, but nobody wants to talk to you about how well your child has understood that concept, or how well they have been able to communicate the concept. So if that is our approach, if our approach is more oriented towards getting them to understand than oriented towards actually getting marks in an examination setup, I think approaches like the small science and all approaches which are more hands-on and driven towards conceptual understanding are going to do wonders.
So one good thing about small science is it is a primary science curriculum, and these pressures are somewhat less at the primary school level. And if also it is not compulsory for CBSE schools or to use, and of course if you're a private school, it doesn't matter at all which textbooks you use. So technically there is no problem in actually using the books as a primary textbook. So the content is the small science content, whatever it is. And so there is that issue of how to complete the syllabus. There is the issue of how to complete the activities. But, like I said, people have struggled, teachers have struggled with it for decades and, have still continued to do this. And they can surely, teachers, for example, from Vedavali Vidyalaya who were not able to join, or Anisa, many others could share their experiences of how they have managed to do it, given, the school has to provide the flexibility. So the principal and the decision makers, the board, has to be on board. Vedavali is a regular SSC school, so it's not, there are CBSE schools, SSC schools, which are using small science. So if the will is there from the decision maker side, it can be done. It's been done in many schools.
I could also just add one thing quickly, Jayashree. So Supreet, also we've also found from our engagement with teachers in schools that again, to start with empathy, because again, like while teachers and the school find it exciting, and even if they feel like they can introduce a small science book, there is that that element of fear that always comes in, even though they're in the primary school section. And so what we try and do there is, like I mentioned earlier, we show elements of the small science book as part of our workshops with teachers, right? And then we ask them to do a few things that are kind of documented in the small science books, and they then see the possibilities of how this approach helps them in their own thinking, and then we leave it up to them in terms of how they want to translate it into their teaching methods, right? So we've realized that not in the first place to say, why don't you use these textbooks, because it's very difficult for them to make that change immediately. So just starting a little bit small, showing them, and also things like even talking about teachers like Anisa who've used the book successfully, even sharing stories like what she just shared with us. Really makes it very effective for other teachers to hear of these stories.
No, very true. I mean, I completely agree with what you're saying. So it's a lot to do with how we want to look at it. And also, I think one more thing which I feel is important is the process. Say even if it's an experiment, you may not get the right result, but the fact that you have journeyed towards the result, you may have got a wrong result, but the fact that you actually journeyed towards the result is a learning in itself. And we have to get children to understand that even the effort that they made in actually making that discovery or leading towards the discovery may not have made it. Say, for example, the pupa unfortunately would not have hatched and the butterfly never came out. Okay, so what would have happened? It was still going to be a learning. So also the way the teacher is actually guiding the students through the entire process is extremely important.
Yeah.
Very
Thanks.
true.
Thanks.